Question 6.3.1. Write down the length of QKT in terms of x, where x is the x-coordinate of k. Now, this can be a bit tricky because now they want it in terms of a variable, and they want the length of this QKT here that I have highlighted. Now, a very good way to think about this, to simplify the problem, is if they want to, let's say we had, for example, the y value q, which was to 4, and the y value t, which was -5. If we wanted the length of QKT and it was a straight line, all we do is we say, well, that's 4 units plus 5 units, 9 units. All right. That would be the length of QKT. Well, there's another way we can look at this. If f of x is equal to y, meaning the function f in terms of x gives a value y, at any point for f of x as well as g of x, let me just write this properly. If g of x in terms of x gives a value for y at any point on the blue graph, and f of x in terms of x gives a point anywhere for y on the green graph, doesn't it make sense that if we wanted to write the distance between the green and blue at any point where they are under and above one another, we can just use our function f of x and g of x, just like we said 4 plus 5 when we had the y values. Well, that's exactly what we're going to be doing here. So let me write it out, then I'll talk about it a bit more. We're going to say, in terms of f of x, 2 root x, so we're going to say f of x minus g of x. So it'll be 2 root x minus 4x squared plus 6. And that will be q to t. Now, what have we done here? You might be wondering why we subtracted the two graphs from one another to give a distance between the green and the blue. Well, a good way to think about this is, if it's not easily seen, this is quite intuitive though, if you think about it like this. If I'm at a position P and I travel a distance d to get to position Q, well, what is d equal to? D is equal to position Q minus position P. And there's where your minus comes from. We're at position F, and we're going to travel a distance to get to position g of x. Or we're at position g of x to get to a distance f of x. So we want to find that position d. So we need to subtract the one graph from the other. And that's exactly what we've done here. And we're done. There's nothing more to do there. We've written f of x in terms of x and g of x in terms of x to give a distance between f of x and g of x. And they just so happen want to see the distance qt. So you write qt. And that is the question solved.